So, in this lesson, we are going to be taking a look at how we can scale an answer based upon using multiplication. So, we're going to be looking at factors that are going to be greater than one and factors that are going to be less than one. So, you can use multiplication to scale or resize something. So, I can determine whether or not a product is going to be larger or smaller by using number sense. So we're using number sense. So it says without multiplying, circle the problem in each set with the greatest product and underline the problem with the least product. Solve this problem any way you choose. So at this point, I would like for you to pause the video and I would like for you to go ahead and circle the ones that you think are the greatest product and circle the ones that you think are, or underline the ones that you think are the least product. So hopefully you paused your video and you, in each of the sets, you circled the one that's going to give you the greatest product and you underline the one that's going to give you the least product. So if we take a look in set A, the product that's going to give us the greatest is going to be B. So B is going to give me the greatest product, and the product that is going to give me the least is going to be C. And here's why. 3/3 times 2. So 3/3 times 2 is really going to be 1 times 2. And so that's going to be giving me the greatest product. The reason that 1/2 times 2 is not going to be the least is because 4/4, so 1 times 5/6, is going to be the least because I'm multiplying a fraction by 1. So the value here of the 1 was smaller than the 2, so that's why C is my smallest one. Okay, if we take a look at set 2, the factor that's going to give us that's going to be the greatest product is going to be A. So I had 3 3/4 times 2 1/2 because both 3 3/4 and 2 1/2 were greater than 1. So my product is going to be greater than both of those values. The product that is going to give me the least is going to be B because 3/4 is less than 1. So 2 1/2, my product is going to be less than 2 1/2. Okay, let's take a look at set C. So if we look at set C, what we have is we have 3/4 times 6/6, 3/4 times 1 5/6, and 4/4 times 5/6. And so looking for the product that's going to be the greatest, the product that's going to be the greatest is going to be B because 1 5/6 is greater than 6/6 and 4/4. So 3/4 of 1 5/6 is going to be greater than 3/4 of 1/6 or 5/6 of 4/4. The product that's going to be smaller. So now I'm comparing 3/4 and 5/6. 3/4 is smaller than 5/6, so it's going to be the least product. All right. So move down to your look back. So how is 3/3 times 2 like 1 times 2? Well, 3/3 is a whole, right? 3/3 is equivalent, is equal to 1. So any time that I have a numerator and denominator are the same value, it's equal to 1. So that's how 3/3 is like 1 because 3/3 is equal to 1. They are equivalent. All right, head into your next problem. And so it says Sue knitted scarves that are 4 feet long for herself and her friends Joe and Alan. After a month, they compared the lengths of their scarves. Some scarves had stretched and some had shrunk. The results are shown in the chart. How had the length of Joe and Alan's scarves changed? So if we take a look at how the length of their scarves have changed, so Sue's is the original amount. Joe's scarf had stretched because it increased by 1 1/2. Alan's scarf had shrunk because it was 3/4 times 4. So because 3/4 is less than 1, this product is going to be less than 4. Okay, for Joe, because 1 1/2 is going to be greater than 4, greater than 1, the product here is going to be greater than 4. Okay, so that's important. When I have a factor that's less than 1, my product is going to be less than the other factor. If I have a factor that's greater than 1, in this case 1 1/2, my product will be greater than the other factor. Okay, so you can take a look here. Here's Alan's scarf, it had shrunk. Here's Joe's scarf, it had increased. So Sue had knitted a scarf for her friend June that was also 4 feet long. After a month, the length of June's scarf could be represented by the expression 3/3 by 4. How did the length of June's scarves change? It didn't change, right? Because we know, this is the color, we know that 3/3 is equal to 1. So 1 times 4 is equal to 4. Scarf did not change. It stayed the same length. Okay. Right, moving into our guided practice. By 3.5 increase its value. So when we multiply a number by 3.5, the value is going to increase because 3.5 is greater than 1. So because 3.5 is greater than 1, my product is going to increase. All right, does the scaling factor always have to be the first factor in an expression? So the answer there is going to be no. It can be either factor. I love that I can't draw eyes. I have to go back and add the dots in. Boop, boop. All right. In 3 through 5, without multiplying, decide which symbol belongs in the box. Less than, greater than, or equal to. And notice I have not done a single multiplication problem example for you guys. It's all been talking about number sense and looking at products. So if I have 3.5 times 2 2/3, is that going to be less than, greater than, or equal to 2 2/3? So I take a look at both by factors. 3.5, actually I'm going to take a look at 3.5 because I'm comparing it to 2 2/3. 3.5 is going to be greater than 1. So here my answer is going to be greater than 2 2/3. Okay, we take a look at 4/5 times 2 2/3, and I'm comparing that to 2 2/3. So I look at 4/5. 4/5 is less than 1. So that means my product of 4/5 times 2 2/3 is going to be less than 2 2/3. If I take a look at 4 3/5 times 4/4, 4/4 is what I'm looking at for my scaling factor. 4/4 is equal to 1. So this is going to be equal. Okay, so that's what I'm doing is I'm taking one of my products, I'm comparing it to 1, and I'm going to see when I do that comparison to 1, is my product going to be greater than the other factor, less than the other factor, or equal to the other factor. All right, so let's go ahead and we're going to come down and do this. You'll notice that you have a lot of products. We're going to go through and do some examples for you, just so you guys can get a little bit more practice with me. If you are at the point that you are like, nope, this is strong, I've got this, I don't need, then you're going to go ahead and you're going to do 6 through 21 all. Okay, so you're going to get all of that practice in. And then on your math practice and problem solving, I'd like for you to do 22. I'd like for you to do 24, 25, and then 27 and 28. So those are your problems that I'd like for you to do today. I'm going to go through and do some of the 6 through 21 with you guys, and then but if you feel like you've got this, you understand how to use multiplication and scaling, and you don't need those other examples, go ahead and start working on your independent practice and math practices and problem solving. Write down this row, and then maybe do a couple others up here. So again, everything I'm doing is a comparison to 1. So I'm looking at the factor that is going to stay the same. So 1 2/3 and 1 2/3 is what I'm comparing. So I'm looking at 2.5. 2.5 is greater than 1. So because 2.5 is greater than 1, my product is going to be greater than 1 2/3. Okay. Number 9, I have 2 2/5, 2 2/5. So I'm looking at 1/3. 1/3 is less than 1. So my product is going to be less than 2 2/5. Okay. 2 and 1/5 times 1/10. I'm comparing that to 2 and 1/5. So 2 and 1/5 and 2 and 1/5. I look at the 1/10. 1/10 is less than 1, so my product is going to be less than 2 and 1/5. 1 and 1/12 times 1 and 3/4, and I want to see if my product is going to be greater than or less than 1 and 3/4. Well, 1 and 1/12 is greater than 1, so my answer is going to be greater than 1 and 3/4. All right. So without multiplying, so I'm going to come back down here to 18. I'm going to do 18 with you guys. Without multiplying, we are going to order the products from least to greatest. So I'm going to order 2 times 3/5, 2 and 1/4 times 3/5, 3/4 times 3/5, 5/5 times 3/5. So really, because I'm multiplying everything times 3/5, I'm really just looking at 2, 2 and 1/4, 3/4, and 5/5. So I look for the smallest one. The smallest one is going to be 3/4. So it's going to be 3/4 times 3/5. That's my first product. My next product that I'm going to do is, so that one's gone. Nope, I'm gonna cross it out. I have 5/5 times 3/5, 2 and 1/4 times 3/5, and 2 times 3/5. My next one is going to be 5/5 times 3/5. That one's now done. Cross it out. And then I'm doing least to greatest. So notice again, least to greatest. Down here, it's going to be greatest to least. Just want to have you guys catch that so you don't do them all least to greatest. And then my next one is going to be 2 times 3/5, because 2 is my next largest factor. And then it's going to be 2 and 1/4 times 3/5. So there's my products in order from least to greatest. Okay. All right, let's pop down here. Let's do 21 as an example. So I'm going to start with 21. So you're going to end up doing 19 and 20. So 3 times 1/3, 4 times 1/3, 2 and 2/3 times 1/3, and 2 and 1/3 times 1/3. So I start with my greatest this time. So it's going to be 4 times 1/3. That was my greatest. My next greatest is going to be 2 and 2/3 times 1/3. My next one is going to be 2 and 1/3 times 1/3. And my last one is going to be 3/3 times 1/3. So you're going to go ahead and you're going to finish the rest of the problem. So you're going to do 7, 10, 13, 16, 8, 11, 14, 17, 19, and 20. And then your math practice and problem solving on the back of the page for the ones that I've already assigned.